All right, guys. All right. Yes. So today we will be looking at where is that my guy? Kubernetes course content. We will be looking at logging. Yesterday we saw what? Persistent volume. All right. Now we'll be looking at what? Logging with what? ELK stack. Okay. Which is the whole of what? 17. Whole of 17. ELK stack. What is ELK? ELK is a three-letter word. Elasticsearch, Kibana, and what? Logstash. Elasticsearch, Kibana, and what? Logstash. ELK. Okay. So this service, all right, is a service used for observability, logging, and observability. Let's look at the proper definition. Let's come here. The ELK Stack is a powerful open source data analytics platform consisting of Elasticsearch, Logstash, and Kibana. It has three major components: Elasticsearch, Logstash, and Kibana. Now let's pick them one by one. What does this guy do? The Elasticsearch is a log.
Boss,
Hello?
boss, please. Your screen is not showing from my side. I don't know if it
Log
is
out now.
everybody.
Log out for me, please. Ebenezer, confirm.
It's not showing.
Ebenezer,
I think it's from your side, though. It's from your
It's
side.
not showing from my side too.
I don't talk since now. When people themselves. I just keep quiet. Since I don't read, I don't the record. Oh, man, they active. Active. All right, guys. All right. Apologies. Now let's go back. Thank you for that, Ellie. Now, ELK Stack is a powerful. Can you see it now? Confirm. Can you see it?
Yes.
All right. Let's move
Yes.
on. Let's move on. ELK Stack is a powerful open source data analytics platform consisting of one, Elasticsearch, Logstash, and Kibana. Let's go back to our board. Now, ELK Stack has three components. Elasticsearch is one component. Kibana is another component. Logstash is another component. Now, what are these things? Elasticsearch, they have their functions. The function of Elasticsearch is basically used for what? Elastic. It does what we call log aggregation. Abi? Elasticsearch. Wait, let's look at what it does. Elasticsearch. Let's look. Elasticsearch has quickly become the most popular engine and is commonly used for log analytics, right? Log analytics, full text search, all right? Security intelligence, business analytics, and operational intelligence use cases. All right. So now, one of the major job function of Elasticsearch is it does log aggregation. Right? It aggregates the entire log. Look at now. This is the flow. Logstash collects logs. When it collects the log, it doesn't keep the log. Logstash, it does not keep log. The service that keeps the component that keeps log is the Elasticsearch. It aggregates the logs, right? So this log will be inside of Elasticsearch, right? Then this log will be forwarded from Elasticsearch to your what? To your Kibana. Your Elasticsearch is just a character. You access logs on Elasticsearch via API. All right, via API. So for you to visualize, see your logs, you use what we call what? Kibana. So Kibana is a visualization tool. You see everything glaring. Why Elasticsearch is to aggregate the log. And Logstash is it collects the log from different sources. All right. Now, there is before now, this part wasn't there. This part. That part wasn't with these components. But as they keep modifying, all right, optimizing the tool, all right, the service, they realize that it is necessary, all right, to start bringing in things that will make log collection, log analytics look simpler and easier, right? Then I came up with things like audit bits, file bits, metric bits, packet bits, win log bits, right? Etc. Right? They can call it what? Lib bit, library what? Bits. So in today's class, right, our flow will be file bits, Logstash, Elasticsearch, and Kibana. This file bit will get the logs. It's going to pick the logs from within your Kubernetes cluster. It's going to go into all the objects running within your cluster and to pick up the logs, about those objects. All right, it will put it in a file and it will forward those logs to Logstash. Right? In turn, Logstash will forward the logs to Elasticsearch, where they will be stored, aggregated. Then this log will be visible, will be viewed on what? On Kibana. So workflow, guys. All right. So that is the workflow. So what we'll be doing now is we are going to set up a Kubernetes cluster. All right. We will have a cluster. On this cluster, we will just install these components. We'll install this guy. We'll also install this guy to our cluster. We'll install our Logstash. We will install our file bits. That's all, guys. That's all. And any other object that is running here will be what? Will be called the logs of that object will be picked up. And you will view the log on what? On Kibana. You view the log on Kibana. View log. View object logs. On where? On Kibana. Now, Elasticsearch, because it aggregates your logs, it's going to grow. It's going to expand. So that means within Kubernetes, Elasticsearch is meant to work with what? Persistent storage. Persistent storage. You see the reason why we needed to learn persistent storage yesterday, because we will need it. Elasticsearch requires what? Persistent storage. And if it's not there, there's a problem. It will not work. So this is the flow, guys. All right. So I'm going to get started. So I'm going to go through that process of yesterday. All right. So I'll be doing it again because we need a persistent storage for our Elasticsearch. Okay. I'll be doing it what? Again. So I need it. So what do I do? Let me get my AWS. Let's go there. Yeah, I have my new cluster. Let me add the worker nodes. Workers. Next, I need I need more size. T2 T2 extra large. T2 extra large. I just need 2 of it. That should be okay. It's giving me 4 CPUs. All right. Next, my subnets. Next, create. All right. Good. So I know that creating. So I've already gotten connected to my control machine. So on this machine, I have my kubectl, my CLI, and I've already connected to my AWS account, right? So let's download our kubeconfig file from our EKS cluster. So AWS EKS updates kubeconfig -- region is EU West 1 -- name is where cluster. So that's the name of my cluster. There we go. So kubectl cluster -info. I have it. Good. I have it, guys. All right. Great. So let's wait for our kubectl get node to be ready. Let our node be ready. Then we will fire down. But before then, is there any query from this flow? The idea of ELK Stack is all about logging. You want to get logs, insights to your applications that are running. Are they running well? Are they not running well? We need to get an insight. That is what we are trying to achieve. Is there any query, guys? Okay.
All right, Frank, just before we go ahead, right, I wanted to also confirm, okay, with what we're doing now, is it also possible that if I want to pull a data, let's say I have a resource somewhere and I want to connect an API to one extension somewhere, just to be able to pull data for me into a resource, and then from that resource, I cannot begin to use it more like a data warehouse. Then I cannot begin to use it for whatever thing I need to use it for. So my question now is that, is this a way to also, can this this production, this what we just have right now, can it also serve the same purpose?
This is just for logging. See, I don't know what you're trying to achieve. Okay, is to get logs. Your applications, they generate logs. Those logs, if they're not captured, you're going to miss out on them. All right. Now you remember when on Windows environments, when you're saying something you're having this error, they tell you that I go and check Windows events. Right? Those are logs. All right. Look out for logs. So it's just logging. So your applications are creating logs, but these logs, we can't get these logs out of the box. So it is only such tool. This tool has the capability, right, to extract those logs from the applications. If your application is not behaving properly, right, it's having some health challenges. Application is not starting. Application is crashing. What is causing the application to crash? Right? So it's via this process you can get to understand the health status of the application. I don't know if that makes sense. Right? And this other method you're calling is something different entirely. This is just logging. You're collecting log. Log is very important. It's an important concept. It's a topic that infrastructure and developer, they normally have log ahead. They normally have issues, problem, quarrel. I need log. I need to see how my application is behaving. All right. So it's not about what you're trying to want to achieve. No. This is log. This is log management. That's what we are doing today. Is log management. We can't do any other thing with this thing. This service is the job of this service to get us log. All right, is to get us log. I don't know if that makes sense. I didn't hear you. All right, so our notes are ready. So we'll now go through the process. First, we'll set up what? Our persistent storage, right? Here's our persistent storage, and this is the document. I'll go very fast, guys, because we did this yesterday. Very, very fast. Okay. EBS. Where's our EFS? EFS, right? So I'm starting with this. Copy that. Just open your eyes, guys. There we go. We have a file, right? IAM policy. Now, step 2, copy all of this to create the IAM role. So, based on that file, all right. So this rule this policy, has been created. Then step what? Step 3. So we are going to grab our words OIDC. Grab your OIDC cluster. The name of my cluster is what? Cluster. I have my OIDC. So let's save it. Let's save our OIDC. And our OIDC. Then the next step, right? I need to create IAM policy. So copy this. Copy. And first bring it down here and make those changes. So what are the things we need to change? We need to change our OIDC from here. The value. Paste that. What else? Our region. EU West 1. EU West 1. What else? We have this to contend with. Paste. There we go. All right. And our region account ID. Sorry. So this is account ID. So account ID is let's go and bring up our account ID. So I'll go to my AWS, right? Come here, copy my account ID. There we go. There we go. There we are. I think we are all good. All right. We are all good. So copy this thing, copy, come to your terminal, and bam, we have the file. We have the file. Congratulations for waiting. You know, Patrick, congratulations for what now? All right. All right. So that was step 4. Now, step 5, let's go there. Copy this guy. Copy. And normal. Okay. And all right. Cut that out. Do we need to do one thing? Then let's run that. Yeah, we are. We are good. Good. So this role has been created and the policy has been attached. Okay, great. So that was step 5. Step 6. Okay, attach the policy. Come here. All right. Same thing. What else do we need to change? We need to change account ID. Move this. Account ID. which we have it up here. So here's our account ID. Here we go. Then let's arrange this. All right, enter. Attached, right? Step 7 is we need to create this file. Copy this, copy, come over here, create that file. All right, good, and paste this entire content. Now in here we need service accounts, right? So our AWS account ID. Come here, AWS account ID. Go back over here, come here, copy, come. There we have it. That's all, guys. Escape, escape, save and quit, save and quit. Good. Now let's come back to our document. So we need to apply that. So copy this, apply, apply. There we go. So the service account has been created. Step 8 says we download this stuff, download this file, public ECRO driver. All right, so come over here, let's download it. So go to the front, there's a special character there, so I need to remove that special character. All right, so what was I saying? I do not have git, right? So sudo yum install git-y. So it's complaining of git. Now that git has been installed, let's rerun that process. Okay, good, we have it now. So you can see we have this file, public ECRO driver. So we need to go into this file, right, and modify this section, the annotation section. So copy this section, copy, come here, open the file, public, wherever, and here is the section, EFS controller service account, right? So we need to replace our account ID with our account ID. Good. So I'll go and fetch my account ID one more time. Copy, come here, and I'll paste it. There we go, guys. Right? Annotation is this. Yeah, we have it. Escape, save and quit. Save and quit. All right? Good, guys. Good. Now we need to apply. Apply. So let's apply that file. Copy, come here, and apply. There we are. All right? Great. Now, because we are not using Fargate, we are going to skip this method, this step. Where our node are not Fargate. We have node, right? So I'll come to what? Creating Amazon EFS file system, right? So first I need to what? Get my VPC ID. So this should give me my VPC ID. My cluster name is cluster. Cluster name is cluster. There we go. So this is my VPC ID. Copy it. Bring it here. Keep it safe. Okay. The next stage is what? Get your what? CIDR block. Right? So my CIDR block should be replace your VPC ID with this. There we go. We have our what? CIDR block, right? VPC CIDR. Now, step 3, create a security what? Group. Copy that. Come here. So I'll be replacing this with my what? VPC ID. And that's it. All right. Enter. It tells me that the security group has been created. So we need the security group ID. So let me save that as well. We need it. The next step is step 4. Step 4. So what do we need? My CIDR is this. And the security group ID, which we have as this. And that's all. That's all. Great. So the next is to create what? The EFS file system. And that's it. And hit enter. Created. So we have our what? File system ID. Copy it because we need it. Come here. There we go. Now, the last is to create a mount point. Okay? Create a mount point. So come over here, paste that. We need what? Security group ID. So we need security group ID. Our security group ID is, where is that guy? Is this? Are you sure? All right. There we have it. Then subnet ID. I'll come back to subnet ID. Let's take care of file system ID first. File system ID is this. Then the subnet ID. Let's go back. So for my subnet ID, I'll go back to my what? AWS account. Duplicate. All right. Go to what? VPC. VPC. And subnet. Let me take subnet 1. Subnet 1. And there we have it. Enter. So we've created the first mount point. So create the second mount point. So the only thing we'll change here is just the what? Subnet ID. I'll come to what? Sub 2. Sub 2. Paste that. Enter. The last but not the least is sub 3. Sub 3. There we go. All right. So we are through with this whole step. This whole step, right? Now we're now open our what? We'll take it further. Okay. So we are going to what? Clone this repository, right? So that we can install our what? Our persistent volume claim, and what? And storage class. Let's go there, guys. So what do I do? I'll say what? Git clone that. There we go. We have it. All right. Now I will need to go into AWS EFS. I'll change directly to examples. I'll change directly to Kubernetes. And I'll change directly to multiple pods. Then I'll copy this guy. So copy recursively spec to where? Dot dots in 4 places. There we go. So I now have this guy here. All right. I showed us this thing yesterday. Great, guys. So go into spec. So under spec, I have my claim, PV, and what? Storage class. Let's open the PV. So Vim PV. So I need to increase this guy, increase my storage capacity. Let's say to 10 GB, right? 10 GB. Then I need to replace this volume handle with the file system ID of our EFS. Our file system ID is this guy. So replace it. Copy. replace. There we have. That's all, guys. That's all. All right. Escape, save and quit. All right. So I'm gonna cause an error, one serious error, when we shall install Elasticsearch. All right. I won't correct it now, so that you will learn from that challenge. That's in the future, if you find yourself in an environment that need Elasticsearch, all right, you can comfortably install it without any error at all. Right. But I'll show that error once we get there. Now we are good. Let's go into the claim file. The claim, let me take 10 GB. My claim 10 GB. All right. We are good, guys. Now let's apply this, guys. So kubectl apply -f pv -f claim -f storage. All right. Hit enter and it creates this. So kubectl gets pv. We have this. So this claim slash this slash claim name. What this thing means is the namespace. This guy is deployed in the default namespace. All right. And my PVC, the same thing, has already claimed the volume. All right. Great. And my storage class SC, we have it there. All right. Good, guys. Good. Now that we have set up our persistent storage, we are through with persistent storage. Let's now start installing these components, right? The file bits, the Logstash, the Elasticsearch, and Kibana into our cluster. And to do this, I have a repository, right, which we are going to work with. Okay. First, I will install what? Elasticsearch. But before then, let me clone this repository to my local machine. Copy. Clone. Git clone. I have it. So the file name is too long. Let me rename it. So move this guy to ELK Stack. I've renamed it. ELK what? Stack. Okay. So I can remove some files here. There are just too many in my face. Remove this. FS driver. Remove AWS CLI. I think we are good. Okay. Now I'll go into ELK Stack. Under ELK, I have Elasticsearch, that. Now, let's edit that Elasticsearch. Let's go into that Elasticsearch. So this Elasticsearch comes with a persistent volume. I don't want this persistent volume because I have my own persistent storage. So don't need it. So delete this guy. All right. Let me save it and I'll come back. Now let me go to my GitHub. Let me also remove it because that's my account. Edit. I don't want this part. All right. Commit. Good, guys. Good. Okay. Now let's run Elasticsearch. So let me go into Elasticsearch one more time. So let's explain. So this will be deployed as a deployment, right? In the namespace login. So I don't have this namespace. I need to create this namespace. And match label, the image of Elasticsearch is version 7.17. And these are environment variables. Elasticsearch runs on port 9200, right? So these are resources and limits. Don't worry. When we get to the topic of resources and limits, you understand it properly. All right. Yeah. Now this is a mount point, volume mount points. Okay. So I can change this guy. This should be, name should come up. Hey, undo. Why? No. Undo. Paste. Okay. All right. So the mount point is elastic storage. The mount path is this user share Elasticsearch data. Then the persistent volume. The persistent volume claim. Our persistent volume claim is EFS dash claim. This is where you need to specify your what? Your persistent volume what? Claim. The claim name is what? EFS dash what? Claim. That's all, guys. That's all we need to do. The rest is service. That's all. Escape. Save and quit. And let's run this Elasticsearch. Then before then, let's create the namespace. kubectl, create namespace, login. The namespace has been created. So if I say kubectl get namespace, I have here that a namespace called login was created. Now let's apply our Elasticsearch. kubectl apply -f elastic.yaml. So this is the first component we are creating, right? Let's check this component. kubectl gets pod, because this guy runs in the namespace login. Let's check. It's showing pending. Let's check. It's still showing pending. Let's check the log. Why is it showing pending? kubectl logs for this guy in the namespace login. There's no log. There's no log. Let us describe it. Describe pod. Describe pod, then the pod name. Let's check. It says that failed scheduling. So this PVC and something that is very, very critical. All right. So that any small mistake you make, it will fail. It says persistent volume claim, EFS claim, not found. But it's there now. kubectl gets PVC. We have it. All right. It's there. Okay. But saying it's not found. Very funny. Now, here is the problem. Guys, watch, be very attentive. This Elasticsearch is running on this namespace login. All right. Meanwhile, your persistent volume is running in where? In the default namespace. When your persistent volume is on a different namespace from your services, from your objects, your pods, they won't communicate. So this pod that is showing pending, kubectl get pod in namespace login. It's on a different namespace. It's still showing what? Pending. It's still showing pending. It will never go out of that status pending, because it's trying to connect to a storage. It's not seeing that storage, because the storage is on a different namespace and he is also running on a different namespace. So for we to correct this behavior, both your objects, both your services, your pod, your applications, and your persistent volume must be in the same words namespace. So let's quickly correct that anomaly. So what I will do first, I will delete the persistent volume. Why do I need to delete the persistent volume first? Because persistent volume is dependent on, sorry, I'll first delete the persistent volume claim. Why do I need to delete the persistent volume claim first? It's because the persistent volume claim is dependent on the persistent volume. If I try to delete persistent volume, my system will hang. The process will hang. Let's try it. kubectl delete. Delete what? PV. What's the name of the PV? EFS PV. Enter. So this process is hanging. This process will hang because what? Something is dependent. It's already attached to the persistent volume. All right. So I have to control C. It will never end. I'll delete the PVC first. Delete PVC. EFS claim. If I hit enter, it goes directly deleted. If I check kubectl gets PVC, nothing. Now I can delete my what? Persistent volume. Or maybe it may have been deleted. kubectl delete. Delete what? PV. It tells us that PV is not found because the moment we deleted our persistent volume claim, it released our PV. So we are clean. So kubectl gets PV. We are clean. Now let's go back to our PV file. All right. So vim spec PV. Open that file. So I need to place this my persistent volume in the namespace, in the same namespace as my what? Elasticsearch login. So it has to be in this namespace login. Escape, save and quit. Now, so far, this is your kubectl gets pod in namespace login. This guy is still in what? Pending state. All right, still in pending state. Now, I also do the same thing for my what? Claim. The namespace is what? Login. How about my storage class? I still put it in the same namespace. Namespace login. You are good. All right. Now let's recreate the PV, PVC, and what? And the storage class. So I'll say what? kubectl apply -f dot spec. I'm doing dot spec because I'm in a different directory. I hope you understand. I'm in a different directory. -f dot spec claim -f dot spec storage class. So if I run this, it recreates everything. Now let's check. kubectl gets PV. Now you will see that this name has changed from default to where? To login. That is what is the namespace, right? The namespace slash the name of what? Of the object, EFS claim, right? So if I check my PVC, I have my what? Okay, PVC, sorry, now is now in a different namespace, namespace login. You can see we have our PV and our what? Our PVC. Now let's go and check our Elasticsearch. kubectl get pod in namespace login. Let's see what has happened. It's now showing error. All right. Let's describe it. kubectl describe. Before it was showing pending, no. Now it has go away from pending and it's now showing what? Error. Let's describe. Copy and paste. You know, before we couldn't, it couldn't download the file, the image. It couldn't download the image. Now it was able to download the image. All right. This was the old error. This was the old error. Error getting persistent volume. Okay, this is the new one. Login. This is the new one. All right. Login this. Okay. All right. So this is what I will do. Because if we don't recreate it, it will see. Are you not seeing it now? Are you not seeing it now? It has automatically healed itself. It has healed itself because it has found what? It has found the persistent volume claim. If I describe that guy again, describe this guy now, everything should be free and fair. Okay, we're still having all these old errors. It's old errors. But we are good now. As you can see, our Elasticsearch is popping. It has gone back to what? Crash loop backup. Let's see the reason why it is crashing. Let's check the log. Let's check, guys. kubectl gets, sorry, logs. Right? Let's check the logs. What is it saying? Saying that error port is not found in namespace. Okay, sorry. The namespace is logging because we've changed namespace, guys. Logging. So these are the logs. So what is actually, it's saying access denied. Access denied, user share, Elasticsearch, data node. It's trying to access this file. And this file is owned by root. It's owned by root. And the Elastic user is trying to access that file. Right? So this is what we'll do. Or maybe there's no access to that file. Node. All right. So I will go back. I will try and not execute. What I will do is I will edit this file, Elasticsearch. Right? I'll come down here. I'll go to the volume mount, the mount part. All right. I'll remove this thing. I can just copy it, comment it out, comment this guy. Then all I need, I just need only /data. That's it, right? For obvious reasons, I don't know why it's throwing up that error. Okay, escape, save and quit. Now let's reapply. kubectl apply -f, apply what? Elasticsearch. Recreated. Now kubectl get port in namespace login. So Samba is now running. All right, everywhere is now skewed. Now let's see how we can access our Elasticsearch. Let's see the content of the Elasticsearch. If Elasticsearch is actually working. So what do? I'll say what? kubectl get port in namespace login -o wide. I want to check the node on which my Elasticsearch port is running. So my Elasticsearch is running on 1.88. So I'll go to my AWS. Come to node. I'll look for 1.88. So this is 1.88. I'll copy it. Come to my browser. So I need to know the service. All right. So I'll say kubectl get service. The service for my Elasticsearch is this. However, this guy is running as a cluster IP. So I'll go and edit this service. All right. I'll edit that service. So because I want to view it in the browser externally. Sorry. All right. So I'll edit it. So once you finish editing, you can always put it back because it's not always nice you expose your Elasticsearch. All right. Edit service name. The service name is this, Elasticsearch. So I'll come to the bottom and change what? My type from cluster IP to where? Node ports. Escape, save and quit. Done. Now if I say kubectl get service, it's now running as a one node port. On port what? 31941. Copy this. Come over here. Column 31941. However, this will not run because the port is not open on the node. So what do? Come here, select this port, come to actions, security, change security group, and add your what? Frank keys infotech, and say what? Save. The moment I do this, we should have our Elasticsearch. Let's check up our Elasticsearch if it's coming up. All right, let's see. Is it okay? Now we have our Elasticsearch. You can see pretty. Now Elasticsearch is up. Tells us that Elasticsearch is this, cluster name is that, cluster UID, blah 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 blah. This now tells us that your Elasticsearch is working. All right. At this moment, we've not deployed Logstash. We are still on Elasticsearch. So let's now deploy the next component, which is what? Logstash. So this will be the first component in your cluster. The next will be what? Your Logstash, because we have to deal with storage, persistent storage, the challenges around persistent storage, the friction. All right, we need to make sure that there's no friction, is well lubricated. The romance between Elasticsearch and persistent storage there's a free flow. All right, next now is what? Logstash. Let's look into Logstash quickly. All right, so come back here. So we have what? Logstash. Before then, let's check on our Logstash. So let's see what and what, or let's explain things. So now Logstash has different section. It has a config map, it has a deployment, and it has a service. All right. Now, a config map, I'm creating a file called logstash.config. It's a configuration. So what's this configuration doing? Now, Logstash is going to accept input. It's going to accept an input. So Logstash configuration has 3 sections. It has the input section. All right. It has the input section. It has the filter section, and it has the output section. I come again. It has 3 sections. The input, the filter, and what? The output. The inputs and the outputs are very important. All right. However, the filter is also important, but optional. All right. Great. Let's explain the input. The input means, where is Logstash going to get the logs from? Logstash has to get the logs from somewhere. Something should be injecting logs into Logstash. And that service is a bit. It's a bit service. And file bit. The bit is what? File bit. And file bit runs on what? Port 5044. So file bit will be injecting, as what you see from our diagram, file bit will be injecting logs that he has collected within our Kubernetes cluster. This guy has collected some logs from our Kubernetes cluster and is injecting those logs as an input into your what? Into your Logstash. Baba, stay where. No stress, baby. Oh. All right. The Logstash is going to output that guy into your what? Elasticsearch. Let's continue, guys. Come here. So input is from the file bit. The output. So Logstash is outputting it to where? To Elasticsearch. Within the Elasticsearch, you need to specify the destination, the host, Elasticsearch host. So by default, within the cluster, this is how Elasticsearch is defined. The service name dot the namespace. Yes, are you seeing it? That thing is namespace dot svc.cluster.local. This is a local service within Kubernetes. The service name is a full DNS of a service within Kubernetes. The service name dot the namespace dot all of these. All right. Now, in which format is your Elasticsearch going to create the indices, the index in the indexes? So in this format, All right. So this, you see this format in Kibana. Once we get to Kibana, so in this format, we want Elasticsearch to format our logs, our indexes like this: 5 bits dash the dates when this index was created. That's it, guys. Can see the flow. 5 bits push to Logstash. Logstash push towards Elasticsearch. Elasticsearch now push towards Kibana. Let's go on. Now, as a deployment, we have Logstash, blah, 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 blah. Now, Logstash has to configure a container port, because Logstash has to talk to what? To your 5 bits via 5044. All right. Logstash runs on 9600. And also, sorry, okay, Logstash runs on 9600. Okay. Okay. Now, and volume, it has its own volume, blah, blah, blah. And service for Logstash, it's a cluster IP. All right. So we didn't do any changes there. Let's go and deploy our Logstash. So I'll come here. I'll go kubectl apply -f Logstash, enter, created. Now kubectl get port in namespace login. So our Logstash container is getting created. Logstash, it's taking some time. It's taking some time. Our Logstash is now running. Now that we've created a Logstash, our Logstash is empty. There is nothing pushing log into Logstash. So we need to go and create a 5 bits. So that 5 bits will be what? Pushing logs from our Kubernetes cluster into the Logstash. Let's go there. 5 bits does all of this automatically. It collects the logs automatically. Let's check it out. Same thing, man. So creating what? A config map first. All right. It's creating this file, 5bit.yaml, bit input. All right. So this guy is a location on my Logstash container. All right. Then this way is referencing the host, the Logstash host, Logstash dot the service name dot, because we check the service. If I come in and say kubectl get service in namespace login, the service name is what? Is Logstash. That's why we have it like Logstash, followed by the namespace, then the format. So this is the format of a service, a local service within what? Kubernetes. And this is a daemon set. So a 5 bits will be deployed as a daemon set, meaning that it has, because it's collecting logs on all of the worker nodes in the cluster. So it must run an instance of 5 bits in each of what? Of the worker node. We already know the definition of what? Of a 5 bits. Okay? That's that. As a daemon set. And that's it, guys. That's it. We're not changing anything. The rest of the thing are just arrow back. Right? So let's come here and apply. kubectl apply -f 5 bits. Created. kubectl get port in namespace login. So you can see, because we have 2 worker node, it only created what? 2 instances of what? That's 5 bits. They are all running. Nice, making sense. At this stage now, 5 bits is now pumping logs. How do we know? Let's check. We are done, guys. We are done. Remaining what? Kibana. Let me go to my README file. So in my README file, this is what I need to check out for. I need to come down here. I need to check verify log collection by 5 bits. All right. I'll copy this command. Copy. Come here. So I'll paste this. Then I'll replace this pod. I'm trying to do an exec, but I'm not logging into the pod, into the container. All right. Any of these guys will serve. I'm not logging in. I just want to be outside of the container in my set and list the content of what? This directory. var log containers. What's happening in this directory? That's what I want to list now. So if I enter that, I can see logs. This guy has already picked up logs. Can see now. It has already picked up logs of, these are all the pods in my cluster. These are all the pods in my cluster. So it's now working now like a charm. Okay, great. Now the last up component is our what? It's our Kibana. All right, it's our Kibana. Now, do we need to make any changes on Kibana? Let's check. Come to Kibana. I say deployment is pointing towards Elasticsearch. Nothing. So this will be deployed as a node port because we need to access it from the browser. That's it, guys. So let's come here. Let's apply. kubectl apply -f Kibana created. kubectl get service in namespace login. So this is our Kibana service. It runs on port 3609 as the external port. Let's check the pod. kubectl get pod. So our Kibana, let's check O-wide. On which node is our Kibana running? Our Kibana is running on Kibana. It's running on 2.253. Let's go and check who is 253. 253. So let's attach our security group here. Frank SG. Add. Save. 253, right? Copy this. Copy. Come to your browser. Column 3601. That's the node port. When we do this, Vala, our Kibana is now coming up. Our Kibana is now coming up. Right? We are through, guys. We are done. Right? Now, the next thing I need to do now is I'll click on explore on my own. So this is the first time you're using Kibana, right? It will always show you this. Explore, mind you, Kibana will be the last component, the last component. Now come to these things that looks like hamburger, right? Burger icon, and go to come to where's that place now? Analytics. Come. Is it here? No, it's not there. I need to see overview. Come on. We need to add an index. Create an index. Why is it taking me time? All right, is it discover? Let me click on discover and check. No. Discover. All right, discover. Click here. Come to what? Discover. Right? Discover brings you here. Right? It says you have data in Elasticsearch. Now create an index pattern. So we need to create an index pattern. Click on create index pattern. Now, if you see on my right already, it has picked up that file bit. You can see now. File bit Logstash has pushed the log as an index into your what? Elasticsearch. And Elasticsearch has created an index as a log into Elasticsearch. And Elasticsearch created what? An index for it, right? So if you remember this section of Logstash, come back to Logstash. Logstash, this section, this section, all right? You can see that file bit. The file bit dash the date which it was created, the date. So I'll come here, I'll say file bit dash asterisk. It tells me that your index pattern matches one source. Matches what? One source. Now the timestamp field, I'll come here, click here and select what? Timestamp, right? Once that is there, come here and click on what? Create index pattern. Click on create index pattern. Once that is created, we're going to have our index file bit, and the field tells us that it has 158 fields. All right, and it was successful. Okay, yeah, so we are good now. The next thing you do now, come back to this hamburger and click on what? Discover one more time. The moment you click on discover, look at now, we now have a log. These are the logs. These are logs. These are logs. All right, we have about 866 hits. Okay, now let's create some containers. All right, I want to create a container, right? So this is what I would do, so that to really test if this thing is working. Okay, I'll come to my local machine. I'll come over here. So let's go and create those our Fleetman, whatever. So I will come to program image. All right. So I'll create a deployment. I'll come over here. Google Kubernetes deployment. The first link. All right. Copy this. Come over here. So let me go out. There are other files here. App1, App2, and Nginx. I'll create them as well. kubectl apply -f app1 -f app2 -f Nginx. Right? It will create them. Okay, saying that this namespace not found. Right? So I'll go into that file, app1, and remove this namespace. I don't want this namespace. I want to create it in the default namespace. App2. Oh, remove that namespace. Then Nginx. Remove that namespace. Now let's reapply. Reapply them. There we go. All right. Now let's come here and create our workload. Workload.yaml. Paste. So this will be Fleetman, whatever. Fleetman position or Fleetman queue. Let me just do that Q1. Fleetman queue. So copy. So I just need a single instance of that. So I don't need this. Maybe I will need the environment variable. env. So where's our environment variable? Oh, we don't even need the environment variable ESF. But let me just create it. All right. So our image name should be Fleetman Q. Fleetman Q. Image name is that. So just want something simple. Okay. Escape, save and quit. Let's apply now. kubectl apply -f workload. So that has been created as well. All right. Now let's check if it's running. Get pod. Container creating is also running. Let's check if these guys, our logs, are coming on Elasticsearch. Now the hit we have is how many hits? 866 hits. If I refresh this now, let's see. We had 866 hits, right? So you can see now we now have what 1,000 over 1,000 hits. Let's search let's start with the one that you can come here and search for your application because there are so many logs, guys, so many, right? So many logs, so many guys. So I'll come here now and search for, let me see if I can see Fleetman. Can I get Fleetman? Search. Guys, Fleetman queue. Can you see how fast that was? It gave me 40 hits. All right. This is the image name. Fleetman queue. 40 hits, guys. 40. All right. So this is the message. So this is the actual log, the message. All right. Var log container, Fleetman queue. Okay. So you can open this, scroll. All right. You see information about the message. Go to the message section. See the message section. So if anything is wrong with this guy, you always see it here. Let's cause a problem with that guy. Let's cause some problem. Workload. Let me change this image. All right. I know that image does not exist. Apply. Now kubectl get pod. So I'm going to have image error. All right. Let's see if we can get error image pool. Let's refresh this guy again. Refresh from here. We had 40 hits. We still had 40 hits. All right. Image error. Let me search that keyword. Error. There's no image. We have something about image. Let me check for the exact keyword. Let's look out for pool. 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 Do we have? We don't have. Error image pool. Do we have? We don't have. We don't have. Let's check agent name, service name, container ID. We always get container ID. Let me clear that. Right? Refresh. Let's check. Fleetman. Q. 96 hits. We're not getting 96 hits as against 40 hits. Let's check. Let's check this message. We now have a lot of messages. All right. Let's check this first message. Open this. This is everything. Let's check that keyword. Pool. Error image pool. Still don't have anything. Still don't have anything regarding Fleetman queue. Fleetman queue. Fleetman queue. Host pod Kubernetes node pod. Okay. 5 bits. No, I'm not seeing. Wait, to Fleetman. Okay. Let's check. $47. This is the latest. The latest, you always see the latest log at the top. You can see the timestamp. Timestamp. This is 50. This is 47. Open this guy. Let's see. Why am I not getting? Why am I not getting that? What is this? Filter value. Message. Varlog. Container. Stream. Bit inputs coded plain. So guys, this, but that's a metrics. Okay. Should have, okay. So this application is not actually generating any log. Guys, what I'm looking for is a metric. This thing is a metric. This thing you're seeing is a metric. All right. So if we needed that metric, we would have installed a metric bit. Let me take your question. What's your question? Yeah, go ahead, Rashid.
So thank you for the presentation, sir. So my question is regarding, let's say for example now, this one we are doing now, the one all these logs we're getting, these are application log. Maybe
Yes.
say for example now the Nginx and stuff we installed. So let's say for example now in a system that was built maybe with Python or Java or Node stuff, and you're trying to like say, okay, in Python now, if you are writing an application, you want to like log a user error, right? Say for not you have application error now, like inside the application itself. Let's say for example, right, you say okay, import login, the login dot error, and you describe maybe the user doesn't have insufficient balance or insufficient stuff or inventory and stuff like that. Will this also be picked up by Bybit with this stats?
Yes. Now we are not able to see those logs because our application is not generating any log. All right. Let me look for those all DNS. I don't know if they are DNS. I don't know if they are generating some log. All right. So we have to
Also,
hit.
one thing, is it possible to create, like this one now? This thing I've already created an index for it already. Is it possible to create a separate index where
That's the file now. That's this file. That's a log. What's that file? That's a log. This year you can add more indexes.
Okay.
All right.
I get you. All right. Thank you.
Okay. Can create index 1, index 2, index 3. All right. So this is it, guys. All right. This is it. So our applications we're not seeing log because they're not generating log. They're not written to generate log. So if they were written to generate to log users' actions, they would have been seeing the logs. Does that make sense?
Yeah, definitely. So.
All right, guys. That being said, we'll now bring this session to a close. But before then, is there any query? All right, I will share this thing with you guys so you can fork this repository. All right, and yeah, you have it. This is your own sample. All right, ELK Stack. All right, guys. So we'll meet tomorrow. Meet tomorrow. We'll continue with. Let us know. Comment with other contents. Until then, I want to bring the session to a close and see you guys tomorrow. Peace out.
Congrats.